Air Almanac, HO 249 Site Reduction Table for declination, and an HO 249 Site Form to record your findings. There are 3 steps required to establish a celestial line of position: observation, computation, and plotting. The sequence of these steps may be altered depending on which of 2 approaches you select. In the pre-computation method, computation is made for a predetermined time. Then an observation is made at that time, followed by plotting. But we'll use the post-computation method with the observation first. In our example, let's assume an observation was taken on the sun at 1630 GMT. Record your observations on the site form. Body, sun. GMT 1630. Date, 24 January. HS of sun, 32 degrees, 21 minutes. Normally, several corrections, such as atmospheric refractions and instrument error, will be made to the sextant reading. But in this case, we'll assume no corrections. Thus, HO is the same as HS. Now you're ready for the computation stage. Remember, you will be using tables to solve a celestial triangle. To do so, you will need to know the declination of the observed body, the sun, the latitude of your assumed position, and the local hour angle between them. To begin, you turn to your Air Almanac. Open to the page for January 24. Look down the Greenwich Mean Time column to 1630 and read off the GHA of the sun, 64 degrees, 26.8 minutes, or rounded off, 64 degrees, 27 minutes. Declination is 19 degrees, 8 minutes south. List GHA and declination on the site form. Here's where the sun is on the celestial sphere, 64 degrees, 27 minutes west of the prime celestial meridian, 19 degrees, 8 minutes south of the equinoctial or celestial equator. This is one point of your celestial triangle. When the GP sun is translated into latitude and longitude on the Earth, you have one point of your triangle on Earth. Your DR position determines another. Let's say your DR position is 27 degrees, 42 minutes north latitude and 97 degrees, 12 minutes west longitude. Since you are operating in the northern hemisphere, the North Pole becomes the second point on your celestial triangle. The third point is your assumed position. It could be the same as your DR position, but since the HO 249 tables are arranged for whole numbers of latitude, you give your assumed position the nearest whole degree of latitude, or 28 degrees north. You use a longitude for your AP that, when added to or subtracted from the GHA of the celestial body, will result in a whole number for local hour angle. Your DR longitude is 97 degrees, 12 minutes west of Greenwich. You are west of the sun. Remember, figuring LHA in this situation gets a bit tricky. Since LHA is always measured westerly through 360 degrees, this is the angle you are seeking. To compute the LHA of the sun, you must first take the GHA sun and add 360 degrees. This gives you 424 degrees, 27 minutes. LHA is this figure minus longitude. The longitude of your DR position is 97 degrees, 12 minutes west. But remember, the longitude of your assumed position should be a figure that, when subtracted from GHA sun, will produce an integral degree of LHA. If you use 97 degrees 27 minutes, the difference will be an LHA sun of 327 degrees. Now you have established your assumed position. 28 degrees north latitude and 97 degrees 27 minutes west longitude. This, then, is your celestial triangle translated into usable components on Earth. You know this side, the co-latitude of your assumed position, 90 degrees minus 28, or 62 degrees. This side is the declination, or polar distance of the sun, south 19 degrees 8 minutes plus 90 degrees, since it is located in the southern portion of the celestial sphere, 109 degrees 8 minutes. And this is a known angle, 360 degrees minus your LHA, or 33 degrees. Now, with two sides and the included angle known, you can compute the linear distance side and the true azimuth angle, the elements you need to draw a line of position. In actual practice, you never have to draw the triangle itself. All you need are three elements related to it: the whole degree of latitude of your assumed position, declination of the observed celestial body, and the sun's LHA. The other information you need, HC and Z, is found in the declination volumes of HO 249 site reduction tables. You enter HO 249 with latitude first. Turn to the pages headed 28 degrees. There you have your choice of two tables. One headed declination contrary name to latitude, and the other headed declination same name as latitude. Since your AP latitude is north and the sun's declination is south, you use the contrary name to latitude table. Note there are two LHA columns, the one on the left for smaller angles, the one on the right for larger angles. Use the right-hand column to find 327 degrees. Move across the tables to the column for the whole degree of declination of the sun, 19 degrees, and you read HC for 19 degrees as 33 degrees 11 minutes. A D, or correction factor of minus 49, which we'll discuss in a moment, and an azimuth angle, Z, of 142 degrees. The D value is the total difference, or change, in minutes of altitude between the declination of 19 degrees and the declination of 20 degrees. The sun's declination is 19 degrees 8 minutes, so you must account for the extra 8 minutes of declination. You could use a simple interpolation formula. 8 minutes of declination over 60 equals X, the amount of correction necessary, over the D value of 49. Or X equals approximately 6.5, rounded off to 7. However, this formula is more easily solved by turning to correction table 5 in the back of HO 249. Enter the table with the D value of 49 and move down the minute column to 8. The correction value is read off as 7. Since the D correction value had been a minus quantity, 7 should be subtracted from 33 degrees 11 minutes, the HC of an even 19 degrees. So HC for 19 degrees 8 minutes is 33 degrees 4 minutes. This figure should be entered as HC on your site form. Now for ZN, or true azimuth. The upper left-hand corner of the HO 249 page tells how to compute ZN, your true bearing from Z. You are in north latitudes. LHA is greater than 180 degrees, so ZN equals Z. LHA less than 180 degrees, ZN equals 360 minus Z. In this case, your